So here's a little video lesson on 8.1 notes, finding angle measures in polygons. We're going to go ahead and establish some properties we can kind of relate to with these certain angle measures. It's going to be really helpful to be able to use one of the following values to find a remaining value or determine the number of sides in a polygon. I'm going to show you different ways you can kind of approach it, and then you kind of just pick and choose the methods that work best for you. So the first thing that we're going to look at is actually the easiest one, and it has to deal with the sum of the exterior angles. Whenever we're dealing with exterior angles of a polygon, it's always when we extend a line segment, one of the sides of that polygon, we're going to extend it past its vertice, and that angle that it creates with its adjacent segment is going to be considered the exterior angle. And whenever you add up the exterior angles of a polygon, all the exterior angles, no matter how many there are, add up to 360 degrees. This is always true. I don't care if there's 3 sides, 4 sides, 20 sides, 300 sides. Whenever I add up those exterior angles, no matter how many there are, they're always going to add up to 360 degrees. Now, once I know that the sum of the exterior angles is 360 degrees, if I know that my polygon is a regular figure, that means that all of its angles are congruent to each other. So the number of angles is going to be the same as the number of sides. So when I go ahead and take 360 and I divide it by the number of sides, n, that's going to go ahead and give me my equation for each exterior angle. I'm going to use the variable e there to represent that. So an example above where n might be equal to 5 here, and we want to go ahead then and find the angle. If I divide the number of sides 5 by 360, I find that each exterior angle might be equal to 72 degrees. Now this might sound a little confusing, but when you're looking to find the sum of the interior angles of a convex polygon, we're going to go ahead and kind of take every type of polygon and we're going to break it down into smaller polygons. So for example, if I take a hexagon, for example, 1, 2, 3, 4, 5, 6. It's not quite regular in shape, but when I take that 6-sided figure and I stand at one vertex, or one vertice, and I draw diagonals to non-adjacent vertices. This would be adjacent, this would be adjacent, so that would mean this guy, and this guy. When I draw those lines, that's a bad line there, let's fix that. When I draw those lines, what ends up being created is 3 smaller polygons that are all triangles. Actually, not 3. I'm sorry, 4. 4 polygons that are all triangles. The important thing to remember about all triangles is that the sum of their interior angles is always 180 degrees. Triangles' interior angles add to 180 degrees. So the interior angles of a triangle add up to 180 degrees, and I have 1, 2, 3, 4 triangles. Well then, can I just go ahead and take 180 and multiply that by 4? So 180 times 4, that gives me a value of 720 degrees. The sum of the interior angles of a convex polygon are going to be, where that number of sides is 6, is going to be 720 degrees. Now the interesting thing about this is the value of the number of triangles that we found is always 2 less than the number of sides. So for example, when I look at a 7 or an 8-sided figure, That's going to create 6 triangles. I'm going to multiply that by 180 degrees. When I do 180 times 6, I end up with a sum of 1080. Again, 10-sided figure, 180 times a number 2 less than the number of sides, 8. And then that's going to give me 1,440 degrees is the sum of the interior angles. So no matter what the number of sides is, the sum of the interior angles is always going to be 180 times the quantity of the number of sides minus 2. And that's going to give me my sum of interior angles. And SI kind of helps me remember the sum of the interior. We're going to use sum of exterior right here. So we'll call that SE, SI. So the last thing we need to do is find the interior angles of a regular Hexagon, where the number of angles is going to be associated with the number of sides. So the last thing we need to do is go ahead and take the sum of the interior angles and divide it by the number of sides, and that gives me my interior angle. Since all the angles are congruent to each other, if I find one, I found them all. Now remember, the sum of the interior is also equal to 180 times n minus 2, all divided by 2. So sometimes textbooks or people would kind of display that equation to find I. Now over the years I've kind of adapted and added different methods. So a good way to kind of always keep this information stored in one place is to kind of put the number of sides right here. I put my sum of interior right here, my individual regular right there, my sum of exterior right here, and my exterior angle right there. I kind of break it down in this little chart, and it helps me kind of keep my information organized, and it helps me figure out what I need to find and what I'm given. This value is always given in your chart. This is always 360, no matter what the number of sides is, always. To find E, all you have to do is go ahead and take away or divide 360 by the number of sides, divided by the number of sides that's listed above. Again, we talked about the sum. The sum is always going to be 180 times n minus 2. And to find I, we're just going to go ahead and take that 180 n minus 2, and we're going to divide by n. I and n only apply when it's a regular polygon. A regular polygon. Okay? Now let's just look at an example of that. Let's say this is 3 sides. What would SI, I, and SE be? And E. Well, SE is always 360, and when I divide 360 by 3, I get 120. When I do 180 times 3 minus 2, I just get 180, so the sum of the interior is 180 degrees. The interior then is going to be divided by 3, so that's 60. Now there's another special relationship that occurs in this chart, and it's the relationship that E has with I. Since E and I are adjacent to each other in their figure, they're going to be supplementary. So when I follow this process of this table, for example for 4 sides, if I know this is 360, I can divide 360 by 4 to get 90. And therefore, if E is 90, then I is going to be its supplementary. It's also going to be 90, because 90 plus 90 is 180. Then if you wanted to find SI, couldn't you then just go ahead and multiply 4 times 90 to get that to be 360? So this chart kind of helps you lay out the details, the information. If you like the chart method, definitely try these next 2 example problems where you have to find some given information. Let's say we have a 7-sided figure. See if you can find SI, I, SE, and E. Also, let's kind of challenge you here. What happens if I only know the fact that this right here, I don't know the number of sides, I don't know SI, I don't know I, but I do know that the E is 36 degrees, and this is obviously 360. See if you can try these 2 problems and come up with their values. After you pause the video, I'll show you my answers. So obviously if it's a 7-sided figure, the sum of the exterior angles is 360. I picked 7 because 7 is not a factor of 360 degrees. So when I put this in my calculator, it's going to be important to understand that we're going to get a weird number, 360 divided by 7, something that is irrational. So once I have that value, I'm going to use this long decimal answer. Okay, I'm going to use this long decimal answer as I go and find my other pieces. So E is roughly around 51.43. Decimal, decimal, decimal. If I wanted to find the interior, I would just go ahead and subtract that from 180 because those two angles have to be supplementary. So I do that. I is 128.57, roughly. It's an estimation. And then if I want to find the sum of the interior, I'm going to take this entire decimal answer and I'm going to multiply it by the number of sides. It's important to keep as many decimal places as possible so my answer for this doesn't become rounded. SI is 900 degrees. If you look at example number 2, if you remember that this is E and this is SE, then if I divide the sum of the exterior divided by the exterior value, I get the number of sides. When I divide 360 by 36, I end up with n equals 10. Once I have that, I might go ahead and jump over here. What's the relationship that E has with I? Well, E is going to have a value that is supplementary to I. So if E is 36, then I is going to go ahead and be 180 minus 36, or 144. And again, once I know that, then I can go ahead and multiply that by the number of sides, and I get my sum to be 1,440 degrees. So if you like the table method, great. If you can remember your formulas up here, even better. Just want to give you a little bit of as many options as possible. So I'm going to kind of do a few of these practice problems with you, but my goal is ultimately to help you, lead you in the right direction, and then you can go ahead and try the practice problems and check the answers with the keys on the notes. Here we have a quadrilateral. So in number 1, we have a quadrilateral where all 4 sides close in here at different angle measures. It's not a regular polygon, but since it's a quadrilateral, I know that the sum of its interior angles is going to be 180 times the number of sides, 4 minus 2. 180 times 2 is 360 degrees, and that means that the angles, x plus 15, x plus 15, plus 2x, plus 2x, their sum is going to be equal to 360 degrees. When I add up x, x, 2x, 2x, I end up with 6x plus 30 is equal to 360. And when I divide both sides by subtract 30 from both sides, I get 6x is equal to 330. Last step is to divide 330 by 6, and x is equal to 55. Since they only want me to find the value of x, I'm just going to stop right there. Okay? So go through that same process with number 2 and see if you can get the answer, which is on the key to the notes. Below here we talked about the relationship that an interior angle has with its exterior angle. If this is the exterior angle and this is the interior angle, since they form a linear pair, their relationship is that their sum is equal to 180 degrees. And therefore they would be supplementary. Supplementary. This is a very important sticking point because it will help us find different angles as well as their sums for interior and exterior. Here we have to find the sum of the measures of the interior angles. So if you're trying to find the sum, there might be 2 different ways to do it. You can go through the table route to try to find that sum of interior. The tough thing about that is you have to start all the way over here at 360 and kind of work your way around the chart. So that's a couple of extra steps to kind of get from point A to point B. It might be more helpful to remember my formula. If I have 180 degrees, and I multiply that by the number of sides minus 2, that will give me the sum of the interior angles. So when I do 180 times 11 minus 2, what I really look for is 180 times 9, and then that will give me a value of 1620. If you like the table method, go ahead and use the table method. There's 16. SE is 360. So I'm going to work my way around. I'll divide 360 by 16 and get an individual of 22.5. Then I'll go ahead then and find the interior angle, which will be supplementary, so I'll take away 22.5 from 180, and that'll give me 157.5. And then finally I'll go ahead and multiply that by 180, or multiply that by the number of sides one more time, and that'll give me a value for the sum of the interior, which would be 2,520. Go ahead and try number 3 and then check it with the key in the notes. Then we're going to move on to example 3 here. The measures of one exterior angle is given in this regular polygon below. Find the number of sides. Here they want me to find the n, the number of sides, given that the exterior angle is 30. So if I know that the sum of the exterior is always 360 and the exterior is 30, all I have to do is do 360 divided by 30, and that will give me my correct number of sides. In this case, it'd be 12 sides. These are pretty easy problems, so go ahead and try 2 and 3 and then check it with the key of notes. The sum of the measures of the interior angle of a convex polygon is given below. Determine the number of sides of the polygon. So here they give me the sum of the interior angles. They want to know the number of sides of the regular polygon. So if the sum is 2,160 degrees, then in my chart, n is what I'm trying to find. 2,160 degrees is what I know. Right below that is my I, but I don't know the number of sides, so I can't really find that right away. So this is where the chart kind of makes it a little more difficult to find the values. Unless you really like algebra, I think the best way to do is to remember that this sum of interior angles is equal to 180, the number of degrees in a triangle, times the number of triangles within that figure, or n minus 2. All I'm going to do now is go ahead and divide by 180. And when I take 2,160 and I divide it by 180, I end up with 12. And then the last thing, since n minus 2 is equal to 12, when I add 2 to both sides, I get n is equal to 14. And 14 is the number of sides that my figure has. Same process can be repeated there in number 2 and number 3 of example 4. And I encourage you to try those as well as check them with the key, which is posted on Google Classroom. One last page here, just a couple example problems for you to try. Not too difficult questions, but you just have to really make sure you read the question carefully. So here I'm going to break out my highlighting tool. We have the measure of an interior angle of a regular polygon, interior angle, and that is 157.5. They want us to find the number of sides of that polygon. So if I fill that out in my chart, they want me to find the number of sides. They tell me that the regular polygon has a 157.5. I don't know the sum of the interior. I couldn't really find that at this point. I don't know the exterior, and I don't know the sum of the exterior. But I need to know the number of sides. Well, the sum of the exterior is 360. I know that. And it'd be really helpful because if I know E, then I can divide 360 by E to find N. So if I know the relationship that I has with E, then I'm golden. So let's go ahead then and subtract 157.5 away from 180 to find the value of the exterior angle, since they are supplementary. 180 minus 157.5 gives me 22.5 for E. Once I know it's 22.5, then I'm just going to go ahead and divide 360 by the exterior angle, 22.5, and that should give me the number of sides of this polygon, which gives me a value of 16, so it's got 16 sides. So, a little tip is really helpful. Whenever you're working, whenever possible, you want to try to work with the exterior angles, because that sum is always 360 degrees. Number 6, let's not work too hard at this one. Let's read the directions carefully and maybe highlight the important information. They want me to find the sum of the exterior angles of a polygon that has 8 sides. Sum of exterior. I'm pretty sure, if I check my notes here, sum of exterior is always 360 degrees. And yes, even for an 8-sided figure, that sum is always 360 degrees. Mr. Ausel, what happens if there's like 2 million sides? Well, the sum is always 360 degrees. Don't overthink it. Read the question, highlight the important information, and answer the question quickly. Find the measure of angle 1. So these objects might not be drawn to scale, but we're going to do our best to kind of check our work. I'm going to work on number 1. You can try number 2 on your own. Here I have, it looks like a 1, 2, 3, 4, 5 angle figure, which means it has 1, 2, 3, 4, 5 sides. This would be an irregular polygon, meaning that its angles are not all the same, but their sum of those angles is going to be 180, the number of sides minus 2. That would be the sum of those angles. So when I multiply 180 times 3, I end up with a sum of 540. Once I find that sum, all I have to do is go ahead and add up the angles I do know, which are 90 plus 110 plus 150 plus 140. And all 4 of those angles add up to 490 degrees. Since they add up to 490 and I'm trying to find the lonely angle 1, all I got to do is subtract 490 from 540 and end up with angle 1 being equal to 50 degrees. Again, number 1 is very similar to number 2, and I think you'll be able to do it. Just remember, there's 6 sides. Alright, let's go ahead and look at number 3 here. Number 3 gives me angle 1. They want me to find it, but it looks like it's on the exterior, the outside of the polygon. So if I want to find the exterior angle, I probably want to know what the rest of the exterior angles are equal to. But I don't know this one right here. So since its buddy here on the interior is 103, that would mean its outside exterior angle would be supplementary to 103. So when I do 180 minus 103, I get a value of 77 degrees. And since the exterior angles of a triangle always add up to 360 degrees, all I need to do is add up these 4 angles and set them equal to 360. When I add up 102 plus 77 plus 126, and I take away that sum from 360, minus 305, I get a value of 55 degrees. You guys are doing a really good job so far in this lesson, but we got one last problem to look over, and this is a really important one because they always love throwing this question maybe on an SOL. I always love giving out this question because it doesn't look like there's a lot of information here, but there's a lot in the details here. So I have a 1, 2, 3, 4, 5, 6-sided figure, which is a hexagon. They also tell me that all the interior angles of that hexagon are all congruent to each other. So it is a regular hexagon. Since it's regular, then I know that all of its interior angles and exterior angles are all going to be the same. So in my 6-sided figure, I know that all the exterior and interior angles are all going to be the same value. Since the sum of the exterior is always 360, this actually becomes a pretty easy problem once I know the setup. Sum of the exterior is 360, so let's go ahead and divide that sum by the number of sides, and that will get me my exterior angle number 1. 360 divided by 6 gives me an exterior angle for number 1 of 60 degrees. Again, like always, go ahead and please rewind, rewatch the video, especially on the parts that might not be totally understandable. Come see and ask me questions in the morning if you have any questions, and also try the practice problems in your practice packet. Good luck, and I'll see you next class.